In this video, we will use the inverse cosine function to determine the measure of an angle if we know a terminal point's coordinates. So let's consider the following task. We want to know the radian measure, theta, of the following angle. So we know from this diagram, we see that the radius of this circle right here is 2 units. So we have a radius of 2 units. And we also see that this terminal point is some distance to the right of the center of that circle. And that distance is actually 0.82 units. But since the output of the cosine function is a number of radii, we should find how many radii to the right of the center of the circle that terminal point is. So since the radius of the circle is 2 units, that terminal point is 0.82 divided by 2 radii to the right of the center of that circle. So we could say that cosine of theta, which gives us the terminal point's distance to the right of the center of the circle in radii, that'll give us 0.82 divided by 2. So then cosine inverse, the inverse cosine function should take that number of radii as an input, and it should output the value of theta. So we should get theta out of that computation. If you plug this cosine inverse of 0.82 divided by 2 into your calculator, you should get a value of about 1.148. So if we look back at our diagram, a measure of about 1.148 radians seems to match up with our situation. So the angle we have, it's between 0 and pi divided by 2. It looks to be a little more than 1 radian, so we can feel pretty confident that theta is about 1.148. Let's look at one more example. So a similar context, we want to know the radian measure of the given angle, and again we have the terminal point's coordinates. And once again, the radius of that circle is 2 units. So we look at the terminal point, and we can say that it's some distance to the right of the center of the circle, and it's actually 0.94 units to the right of the center of the circle. Since the radius of the circle is 2 units, it's 0.94 divided by 2 radii to the right of the center of the circle. So then we might compute cosine inverse of 0.94 divided by 2. And if we run that computation, if you plug that into your calculator, you should get something that's about 1.082 approximately. Now, if we look at this number, it doesn't match up with the situation. The angle we have here in green is not close to 1 radian. So what's happening here is cosine inverse is taking this horizontal distance as its input, and then it's outputting the radian angle measure on the top half of that circle. So what it's actually giving us is this angle right here. So right there is that 1.082. Now if we look at this diagram, we can see that if we start at the 3 o'clock position and then we rotate theta radians, we'll have to rotate another 1.082 radians to complete a full rotation. So from that, we could say that if we start with theta radians, and then we add that 1.082 radians, we should end up with 2 pi radians. And therefore, if we wanted to know the value of theta, theta would be equal to the 2 pi minus the 1.082, and that has a value of approximately 5.2. So roughly 5.2. If we look back at our diagram, a radian angle measure of about 5.2 seems to match up with this scenario. So in cases like this, we need to be a little careful about what the output of the cosine inverse function gives us. It always gives us a radian angle measure where the terminal ray is in the top half of the circle. And if our terminal ray actually points to the bottom half of the circle, we have to do a little extra work.